Graph the quadratic function by making a table of values and determining the vertex. The graph of a quadratic function forms a U-shaped graph, which is called a parabola. Let's begin by reviewing the properties of a parabola. Our given function is in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. The parabola opens upward if a is greater than 0, and downward if a is less than 0. A also changes the width of the parabola. This is based upon the graph of the basic quadratic function f of x equals x squared. The parabola gets narrower if the absolute value of a is greater than 1, and wider if the absolute value of a is less than 1. And then finally, if the parabola opens upward, the lowest point on the graph is the vertex. If the parabola opens downward, the vertex is the highest point on the graph. And the vertex depends on the values of a, b, and c, and it's always given by the ordered pair shown here, where the x-coordinate is negative b divided by 2a, and the corresponding y value is always f of negative b divided by 2a. Looking at the graph of the parabola below, notice how this opens upward, which means a is positive, and the lowest point on the graph, this point here, is the vertex. So when graphing a parabola, it's a good idea to always find the vertex. Going back to our example, notice how a is equal to negative 1/3. Because negative 1/3 is less than 0, we know the parabola will open downward. And because the absolute value of a is equal to the absolute value of negative 1/3, which equals positive 1/3, which is less than 1, the graph of the parabola will be wider than the graph of f of x equals x squared. And now I'll determine several points on the graph of the parabola using a table of values. Every time we select the next value and find the corresponding function value, we are determining one point on the graph. But looking at the function again, because this first term is negative 1/3 x squared, if we select x values that are multiples of 3, the denominator of 3 will simplify out, which will avoid having fractional values for the function values or y values. So looking at the table, this is why I selected multiples of 3. We can select any x value that we want, but selecting multiples of 3 will avoid having fractional values for the corresponding function values or y values. So when x equals 0, the corresponding function value or y value is f of 0. To determine f of 0, we substitute 0 for x, which gives us negative 1/3 times 0 squared plus 3 times 0 minus 2. Simplifying, we have 0 plus 0 minus 2, which equals negative 2. One point on the graph of the parabola is given by the ordered pair 0, negative 2, which happens to be the vertical intercept of the graph because this point is on the vertical axis. Next we have x equals 3. The corresponding function value or y value is f of 3, which equals negative 1/3 times 3 squared plus 3 times 3 minus 2. Simplifying, we have negative 1/3 times 3 squared is 9, plus 3 times 3 is 9 minus 2. Here we simplify before multiplying. As a fraction, 9 has a denominator of 1. There's 1 3 and 3, and 3 3s and 9. Here we have negative 1 times 3, that's negative 3. We have plus 9 minus 2, which equals positive 4. The ordered pair 3, 4 represents another point on the graph of the parabola. The next x value is negative 3. The corresponding function value is f of negative 3, which equals negative 1/3 times the square of negative 3 plus 3 times negative 3 minus 2. Simplifying, negative 1/3 times the square of negative 3 is positive 9, plus 3 times negative 3 is negative 9 minus 2. Simplifying before multiplying here, there's 1 3 and 3, and 3 3s and 9. This gives us negative 1 times 3, which is negative 3, plus negative 9 minus 2, which equals negative 11. And then finally we have x equals 6. The corresponding function value or y value is f of 6, which equals negative 1/3 times the square of 6 plus 3 times 6 minus 2. which equals negative 1/3 times 6 squared is 36, plus 18 minus 2. Simplifying here, there's 1 3 and 3, and 12 threes and 36, which gives us negative 12 plus 18 minus 2. Well, negative 12 plus 18 is 6. 6 minus 2 equals 4. Now that we have several points on the graph of the parabola, let's find the vertex of the parabola. To determine the vertex, we use the equation x equals negative b divided by 2a to determine the x-coordinate of the vertex. Notice b is positive 3 and a is negative 1/3. So we have negative 3 divided by 2 times negative 1/3, which equals negative 3 divided by negative 2/3. Now from here, remember, dividing by a fraction is equivalent to multiplying by the reciprocal. As a product, this is negative 3 times negative 3 halves. Negative 3 as a fraction has a denominator of 1. Multiplying, we get positive 9 halves, which equals 4.5. Let's record the vertex in the table as well, where the x-coordinate is 9 halves, which equals 4.5. To find the y-coordinate, we need to determine the function value f of 9 halves. So f of 9 halves equals negative 1/3 times the square of 9 halves plus 3 times 9 halves minus 2. Well, the square of 9 halves is 81/4, so we have negative 1/3 times 81/4. 3 times 9 halves is equal to 27 halves, so plus 27 halves minus 2. As a fraction, 2 would have a denominator of 1. For this first product, let's simplify before multiplying. So 1 3 and 3 and 27 threes and 81. This product is negative 27/4. Let's write these two fractions as equivalent fractions with the denominator of 4. So multiply the numerator and denominator of 27 halves by 2, and the numerator and denominator of 2 over 1 by 4. This way we'll have a common denominator. So we have negative 27/4 plus 54/4 minus 8/4. Common denominator is 4. The numerator is negative 27 plus 54, which is 27, minus 8, which equals 19. And 19/4 equals 4.75. And now let's graph the parabola. Each row in the table gives us an ordered pair that represents one point on the graph of the parabola. The ordered pair 0, negative 2 represents the vertical intercept of the graph, which would be this point here. Then we have the ordered pair 3, 4. From the origin, we move right 3 up 4. Next we have the ordered pair negative 3, negative 11. Notice how this point is not going to be on the coordinate plane based upon how we scaled the axes. So we'll skip this ordered pair and go to the next ordered pair, which is 6, 4. From the origin, we move right 6 up 4 here. And now let's go ahead and graph the vertex, which will help us make an accurate graph of the parabola. So the ordered pair for the vertex is 4.5, 4.75. Using the decimals will make it much easier to graph than using the improper fractions. So from the origin, we go right 4.5 units, and then up 4.75 units. Up 4.75 would be just below 5 here. Because we have the vertex, we can now make an accurate graph of the parabola. Let's graph this side first because we have 2 points on this half. And on the right side will be a mirror image of this half, which would look like this. This is the graph of the parabola from the given quadratic function. There is one more thing I do want to point out. Every parabola has an axis of symmetry or line of symmetry, which is the vertical line passing through the vertex, which is this point here. And we say the parabola is a reflection across this line because notice how if we were to fold the parabola across this line, one half matches up with the other half. I hope you found this helpful.